Close your eyes and feel the solid ground beneath you. Right now, in this quiet moment, you might think the Earth is perfectly still. But something wonderful is happening. Something so slow and gentle that you cannot sense it with your body, yet so powerful that it shapes mountains and moves oceans. The Earth is breathing. Not with lungs like yours, but with something far more ancient and patient. Deep beneath your feet, the planet's surface rises and falls in a rhythm that spans millions of years. Each breath takes longer than entire civilizations. Each gentle exhale lasts longer than all of human history. Imagine lying on the chest of a sleeping giant. You feel so small and light that you cannot detect the slow rise and fall of breathing. But if you could wait and watch for thousands of lifetimes, you would see the chest moving up and down, in the most patient rhythm imaginable. This is how the Earth breathes beneath you. The solid ground under your home, under your school, under every place you have ever walked, floats on something that moves like thick honey warmed by the sun. Miles below the surface, rock becomes so hot that it flows like a slow river. This flowing rock carries the continents on journeys that last millions of years. Right now, as you rest here, North America is drifting away from Europe. Not fast like a car or even like a walking person. Much, much slower. About as fast as your fingernails grow. If you could live for 1,000,000 years and keep measuring, you would see that the Atlantic Ocean grows a little wider each day. Africa is slowly pushing into Europe, crumpling the land between them into the Alps and other mountain ranges. India continues its ancient journey north, pressing against Asia and lifting the Himalayan peaks a tiny bit higher each year. The Pacific Ocean floor slides under the edges of continents like a massive, slow-moving conveyor belt. All of this happens because the Earth is alive with movement deep inside. Picture a pot of thick soup simmering on a stove. Bubbles of hot liquid rise up from the bottom. They spread out at the surface, cool down, and sink back down the sides. This creates a gentle, rolling pattern of movement. The Earth's inner layers move in a similar way, but instead of taking seconds, each cycle takes millions of years. The heat that drives this movement comes from the very heart of our planet. Deep in the Earth's core, it is hotter than the surface of the Sun. This incredible heat slowly rises up through thousands of miles of rock. Like the soup in the pot, hot material rises while cooler material sinks back down. This movement, so slow and powerful, carries the continents like passengers on a vast, patient train. The train moves so slowly that no human has ever felt it accelerate or brake. But it never stops. It has been moving since the Earth was young, and it will continue moving long after the Sun grows old. You are part of this journey right now. As you lie here, you are traveling through space on a planet that is constantly reshaping itself. The ground beneath you has been to places you cannot imagine. The rocks under your feet have crossed oceans, climbed mountains, and visited other continents. Some of the land around you once lay at the bottom of ancient seas. Seashells and coral reefs that lived in tropical waters millions of years ago now rest high and dry, sometimes even on mountaintops. The Earth's breathing has lifted them up and carried them to places they never could have reached on their own. Think about a leaf floating on a stream. The leaf does not choose where to go. It simply rests on the water's surface while the current carries it downstream, around rocks, past trees, over small waterfalls. In the same way, the continents rest on the Earth's flowing interior while the planet's deep currents carry them on their slow journey through time. This journey connects you to every place on Earth in ways you might never have imagined. The ground beneath you has been moving and traveling for billions of years. It has visited other continents, touched other shores, felt different climates. Your little patch of Earth has its own travel story. If you could read the rocks like pages in a book, you would discover where your land has been. You might find that it once lay near the equator when palm trees grew where snow falls now. Or perhaps it once sat near the South Pole when ice covered what is now a warm desert. The Earth's breathing connects all places and all times. The mountain ranges that seem so permanent will eventually wear away. The ocean floors that seem so deep will someday rise above the waves. Islands will drift together and become part of larger continents. continents will break apart and create new oceans between their pieces. All of this happens through the Earth's slow, steady breathing. The planet inhales by pulling its surface pieces together. It exhales by stretching them apart. Sometimes the breathing creates new land. Sometimes it swallows old land back into the deep interior. As you rest here tonight, you are part of this ancient rhythm. Your body lies still while the earth beneath you continues its patient dance. Every continent, every island, every mountain range moves together in this slow-motion ballet that has been performing since before life existed on Earth. The dance will continue long after you are gone, carrying future generations on journeys to places that do not exist yet. New mountains will rise where valleys lie today. New oceans will open where dry land stretches now. But deep beneath the surface, something even more remarkable flows, rivers of molten stone that have been moving since the world was young, carrying the secrets of how all the continents began their endless journey together. Beneath your sleeping form, far deeper than any well or cave, rivers flow in eternal darkness. These are not rivers of water rushing toward the sea. These are rivers of stone, flowing like thick syrup warmed by a fire that never dies. Imagine honey left in summer sunlight, golden and warm, pouring slowly from a spoon. Now imagine that honey is made of rock, glowing with its own inner light. This is what flows beneath you, carrying entire continents on currents that move slower than growing grass, yet more powerful than any force you can imagine. The stone rivers begin their journey nearly 3,000 miles below your feet, where the heat is so intense that solid rock becomes liquid. Here, in the Earth's deep interior, temperatures reach beyond anything you have ever felt. Hotter than lava. Hotter than lightning. So hot that rock melts like ice cream on a summer day. This liquid rock, called magma, rises up through the earth like bubbles rising through thick liquid. But unlike bubbles in soda that reach the surface in seconds, these bubbles of melted stone take millions of years to complete their journey upward. They rise with the patience of mountains growing, with the steadiness of seasons changing. As the hot rock rises, it spreads out beneath the earth's crust like warm honey spreading across bread. The crust, the thin shell of solid rock that you live on, floats on top of this flowing layer like a raft on a slow-moving river. Your continents, your countries, your hometown all ride along on this ancient current. Picture a leaf floating down a lazy stream in autumn. The leaf does not choose its path. It simply rests on the water's surface while the current carries it around bends, past fallen logs, through quiet pools. Sometimes the current brings leaves together in gentle collisions. Sometimes it pulls them apart, sending them toward different shores. This is how your continent travels through time. North America floats on its river of stone, drifting slowly westward while Europe rides its own current in the opposite direction. South America and Africa, once joined like two pieces of a puzzle, now sail on separate streams of molten rock, growing farther apart with each passing day. The stone rivers flow in great, circular patterns beneath your feet. Hot rock rises up from the deep interior like a slow fountain. At the surface, it spreads out and begins to cool. As it cools, it becomes denser and heavier. Eventually, the cooler rock sinks back down toward the Earth's center, completing a cycle that takes hundreds of millions of years. These flowing patterns create the currents that move continents. Where hot rock rises and spreads apart, new ocean floor is born. The Atlantic Ocean grows wider each year because hot stone rises up along the underwater mountain range that runs down its center. New rock forms and pushes the older rock aside, like a slow-motion conveyor belt made of stone. Where the cooler rock sinks back into the Earth's interior, old ocean floor disappears into the deep. The Pacific Ocean grows smaller each year as its edges slide beneath the continents that surround it. Mountains rise where the moving stone meets resistance. Volcanoes mark the places where the Earth's interior touches its surface. You rest here tonight on a piece of crust that has been rafting on these stone rivers since before complex life existed on Earth. Your patch of land has traveled thousands of miles, visiting climates and latitudes that would seem foreign today. It has been tropical when it now sits in cooler zones. It has been polar when it now enjoys temperate weather. The journey never stops. Right now, As you breathe slowly and peacefully, your continent continues its ancient voyage. The stone rivers beneath you flow with the persistence of time itself. They carry no cargo except the surface of the world. They follow no schedule except the rhythm of geological ages. Sometimes the rivers bring continents together in slow embraces that last for millions of years. When this happens, mountain ranges rise up like wrinkles in the Earth's skin where the land masses press against each other. The Himalayas grow taller each year because India continues its northward journey, pushing against Asia with the irresistible patience of geological time. Sometimes the stone rivers pull continents apart, creating new oceans between lands that were once joined. The Red Sea grows wider each year as Africa and Arabia drift in opposite directions. Millions of years from now, this narrow sea will become a wide ocean, just as the Atlantic Ocean opened when the ancient supercontinent Pangaea began to break apart. The rivers of stone connect every part of your planet in an endless cycle of movement and renewal. Rock that once formed the floor of an ancient ocean may rise up to become part of a mountain peak. Continents that now sit far apart may drift together to become one large landmass. Islands may sink beneath the waves while new islands rise from the ocean depths. All of this happens because the Earth's interior stays hot and active, keeping the stone rivers flowing through deep time. The heat comes partly from the planet's formation billions of years ago, when countless collisions of space rocks melted the young Earth into a ball of liquid fire. It also comes from the slow decay of radioactive elements deep inside the planet, like an eternal campfire that never burns out. This inner fire ensures that the stone rivers will keep flowing for billions of years to come. Your continent will continue its patient journey long after the sun grows dim and the oceans freeze. The Earth's interior will stay warm and active, moving the surface in patterns too large and slow for any single lifetime to comprehend. As you settle deeper into rest, imagine yourself floating peacefully on this vast, patient current. You are a passenger on a journey that began before life existed and will continue long after the last mountain wears away. But these stone rivers do not flow randomly through the Earth's interior. They follow paths carved by an ancient story, a tale of lands once joined together in a single, mighty embrace that scientists have learned to read like words written in stone. Picture yourself sitting at a table with a jigsaw puzzle spread before you. The pieces lie scattered, each one a different shape, each edge curved in its own unique way. As you begin to work, you notice something magical. The pieces want to fit together. They remember being whole. This is the story of our planet's continents. Once, long before the first flower bloomed or the first bird sang, all the land on Earth formed a single, magnificent puzzle piece. Scientists call this ancient supercontinent Pangaea, which means all Earth in the Old Greek language. Imagine standing on Pangaea 300 million years ago. You could walk from what would become New York to what would become London without ever seeing an ocean. You could journey from the future Amazon rainforest to the future Australian outback across solid, unbroken ground. All the world's land stretched before you like one enormous, peaceful country. Pangaea was not the first supercontinent to grace our planet, nor will it be the last. The Earth has been playing this slow game of assembly and separation for billions of years. Continents drift together like old friends meeting after a long journey apart. They stay embraced for millions of years, then slowly drift apart again, each piece carrying memories of their time together. Think of children building with blocks, creating tall towers that eventually topple and scatter. But unlike children's blocks that fall quickly, the Earth's continental blocks move with the patience of growing trees. They come together over tens of millions of years. They stay together for hundreds of millions of years. They drift apart again just as slowly. When Pangaea existed, the world looked nothing like the globe you know today. There was no Atlantic Ocean separating Europe from North America. No Mediterranean Sea between Africa and Europe. No Red Sea between Africa and Arabia. Instead, one vast ocean called Pangaea surrounded the single landmass like a blue blanket wrapped around a sleeping giant. The climate on Pangaea was strange and wonderful. With so much land gathered in one place, the interior regions lay far from any ocean. Imagine walking for months without ever seeing the sea. These inland areas became hot, dry deserts that stretched for thousands of miles. Meanwhile, the coasts enjoyed mild, wet weather where forests of ancient trees grew tall and thick. Strange creatures lived on Pangaea that you would not recognize today. Early reptiles that looked like a mix between lizards and mammals wandered across landscapes that would someday become separate continents. Fern forests covered much of the land. Dragonflies as large as seagulls flew through humid air. All of this life lived on one connected piece of land, unaware that their world would someday break apart. But even as Pangaea reached its greatest size, forces deep within the earth were already beginning to pull it apart. The stone rivers flowing beneath the surface started to change direction. Hot rock rising from the Earth's interior began to push up against Pangaea from below, like a slow bulge forming under a blanket. Cracks began to appear in the supercontinent. Not quickly, like glass breaking, but gradually, like clay drying in the sun. These cracks grew wider over millions of years as the stone rivers beneath pulled the land in different directions. What started as tiny fissures eventually became valleys, then narrow seas, then wide oceans. The Atlantic Ocean was born from one of these cracks. Imagine Pangaea as a piece of warm taffy being slowly pulled apart. First, a thin line appeared down the middle. Then the line widened into a gap. Hot rock from below flowed up to fill the gap, creating new ocean floor. Year by year, century by century, the gap grew wider as North America and Europe drifted in opposite directions. The same process happened in many places around Pangaea. Africa began to separate from South America, creating the southern part of the Atlantic Ocean. India broke away from the southern continents and began its long journey northward toward Asia. Antarctica drifted south toward the pole, carrying with it fossils of tropical plants that once grew when it was part of Pangaea's warm interior. As the continents separated, they carried pieces of Pangaea's story with them. The same types of rocks appear on both sides of the Atlantic Ocean, like two pieces of a torn photograph. The same fossils of ancient plants and animals can be found on continents that now lie thousands of miles apart. Mountain ranges that once ran continuously across Pangaea now appear as broken chains on different continents. You can see evidence of Pangaea's breakup in your own world today. The eastern coast of South America fits against the western coast of Africa like two pieces of a puzzle. If you could push the continents back together, they would match almost perfectly. The same rocks, the same fossils, the same ancient mountain ranges would line up as if they had never been separated. This matching extends far beyond South America and Africa. Australia, Antarctica, India, and parts of Africa all fit together like pieces of a complex puzzle. When scientists first discovered these matches, they realized they were looking at the scattered remains of something much larger and older than any single continent. The breakup of Pangaea created the world you know today, with its familiar arrangement of continents and oceans. But this arrangement is not permanent. The same forces that pulled Pangaea apart continue to move the continents today. The Atlantic Ocean grows wider each year. The Pacific Ocean grows smaller. India continues to push into Asia, making the Himalayas taller. The Earth's puzzle pieces are still moving, still changing, still drifting on their rivers of stone. They carry with them the memory of their time together as Pangaea, and deep in the planet's interior, new currents are already beginning to form. These currents will someday reverse direction, bringing the scattered pieces back together once again. As you rest here tonight, the continent beneath you remembers its ancient unity with all the other continents. It carries in its rocks and minerals the story of when all land was one land, when all shores belonged to the same sea. But this story of unity and separation did not begin with Pangaea, and it will not end with today's continents. Long before Pangaea existed, other supercontinents had their moment of wholeness before breaking apart into pieces that would eventually become Pangaea itself. Sometimes the most important discoveries begin with the simplest questions. In 1912, a gentle German scientist named Alfred Wegener sat in his study, looking at a world map spread across his desk. Outside his window, snow fell softly on the streets of Berlin. Inside, surrounded by books and papers, Wegener noticed something that had been hiding in plain sight for centuries. The continents looked like they belonged together. Wegener traced his finger along the eastern coast of South America, then across the Atlantic to the western coast of Africa. The coastlines curved and bent in almost exactly the same way, like two pieces of a jigsaw puzzle waiting to be joined. If he could somehow push the continents together across the ocean, they would fit with remarkable precision. Most people had noticed this curious match before. Children looking at their first world maps often pointed it out to their teachers. But everyone assumed it was just a coincidence, a trick of nature that meant nothing important. The continents were fixed in place, solid and permanent. They had always been where they were now. They would always stay there. Wegener thought differently. He began to collect evidence like a detective solving an ancient mystery. He discovered that the same types of rocks appeared on both sides of the Atlantic Ocean. Identical minerals, formed in exactly the same way, sat thousands of miles apart on different continents. It was as if someone had taken a single rock formation and somehow stretched it across an entire ocean. Even more remarkable, Wegener found the same fossils on continents separated by vast stretches of water. Ancient fern plants that had lived millions of years ago appeared in both South America and Africa. A small reptile called Mesosaurus, which could not swim across oceans, left its fossils on continents that were now thousands of miles apart. How could land animals and plants that lived at the same time appear on continents separated by deep oceans? Wegener realized there was only one logical explanation. The continents had once been connected. The plants and animals had lived on continuous land that later broke apart and drifted to different places. Wegener called his idea continental drift. He imagined the continents as great ships sailing slowly across the Earth's surface, carrying their cargo of rocks, fossils, and life forms to new locations over millions of years. He proposed that all the continents had once been joined together in a single landmass that he named Pangaea. His idea was beautiful and simple. It explained the matching coastlines, the identical rocks, and the scattered fossils. It suggested that the Earth was not a static, unchanging planet but a dynamic world where even the continents themselves were travelers on an incredible journey through time. But when Wegener shared his theory with other scientists, they laughed at him. The scientific community of his time could not accept such a radical idea. How could entire continents move? What force could possibly push something as massive as South America across an ocean? The Earth's crust was solid rock. Continents were far too heavy to drift around like icebergs on the sea. Wegener had wonderful evidence that the continents had moved, but he could not explain how they moved. He suggested that the continents plowed through the ocean floor like ships through water, but other scientists quickly proved this was impossible. The ocean floor was far too hard and solid to allow continents to push through it. For decades, Wegener's theory was ignored and ridiculed. He died in 1930 while exploring Greenland, still believing in his continental drift theory but unable to convince his fellow scientists. His revolutionary idea seemed destined to be forgotten, another interesting but wrong hypothesis in the history of science. But the Earth itself was about to reveal the secret that Wegener had been missing. During World War II, scientists began using new instruments to map the ocean floor. They discovered that the bottoms of the oceans were not flat, boring plains as everyone had assumed. Instead, underwater mountain ranges ran down the centers of the oceans like the backbones of sleeping sea monsters. Even more surprising, these underwater mountains were made of young rock. Scientists had expected the ocean floors to be very old, covered with millions of years of sediment. Instead, they found that the rocks at the center of the oceans were newly formed, while the oldest rocks lay near the continents. It was as if the ocean floors were being born at their centers and growing outward toward their edges. In the 1960s, scientists made another discovery that would change everything. They found that rocks on the ocean floor contained tiny magnetic minerals that acted like miniature compasses. These minerals had recorded the direction of the Earth's magnetic field when the rocks formed. But the magnetic pattern showed something impossible. The Earth's magnetic field had flipped many times throughout history. North had become south, and south had become north, over and over again throughout geological time. The rocks preserved this history in stripes of magnetism running across the ocean floor, like a barcode written in stone. Scientists realized they were looking at a recording device built into the Earth itself. The ocean floor was a giant tape recorder that had been documenting the planet's magnetic history for millions of years. And the message it contained was clear: new ocean floor formed at the underwater mountain ranges and slowly moved outward toward the continents. This was the mechanism that Wegener had been missing. The continents were not plowing through the ocean floor. Instead, the ocean floor itself was moving, carrying the continents along like passengers on a vast, slow conveyor belt. New ocean floor formed at the underwater ridges and pushed the older floor aside, creating the force needed to move entire continents. Wegener's dream of drifting continents was finally proven correct, 50 years after he first proposed it. Scientists now call this process plate tectonics, recognizing that the Earth's surface consists of large plates that move and interact with each other over geological time. The quiet scientist who had noticed matching coastlines on his map had been right all along. The continents were indeed travelers, riding on moving pieces of the Earth's crust as they journeyed through deep time. His simple observation had revealed one of the most important truths about our planet. But Wegener's story teaches us something even more valuable than the science of moving continents. Sometimes the most important discoveries require not just observation and evidence, but also the courage to believe in ideas that seem impossible to others. The Earth had been keeping the secret of its magnetic memory for millions of years, waiting for the right instruments and the right minds to finally read the message written in its ocean floors. Imagine walking into the most magnificent library ever built. The shelves stretch as far as your eyes can see, filled not with books but with stories written in stone. Each shelf holds millions of years of history. Each page tells of times when the world was completely different from today. This library exists beneath the ocean waves. It covers the entire floor of every sea on Earth. The stories are written not in words but in invisible stripes of magnetism that run across the ocean floor like the lines on notebook paper. Deep underwater, where no sunlight has ever touched the rocky seabed, these magnetic stripes lie quietly in the darkness. They have been recording the Earth's secrets for millions of years, waiting patiently for someone to learn how to read their silent language. The ocean floor creates its own pages in this vast library. Along underwater mountain ranges that snake through the deep sea, hot rock rises up from the Earth's interior like molten honey. When this liquid rock touches the cold ocean water, it hardens into new stone. Day by day, year by year, new rock forms and pushes the older rock aside, like pages being added to an enormous book. But here is where the magic happens. As each new page of rock cools and hardens, tiny magnetic crystals inside the stone turn to point toward magnetic north, like millions of microscopic compass needles all aligning in the same direction. These crystals freeze in place as the rock solidifies, creating a permanent record of which way the Earth's magnetic field was pointing when that piece of ocean floor was born. You might think this would create a simple pattern, with all the magnetic stripes pointing in the same direction. But the ocean floor tells a far more fascinating story than that. The Earth's magnetic field is not as steady as you might imagine. Our planet acts like a giant magnet, with invisible lines of magnetic force flowing from the south magnetic pole to the north magnetic pole. But this enormous planetary magnet is restless and changeable, like a compass needle that occasionally decides to spin around and point in the opposite direction. Throughout Earth's long history, the magnetic field has flipped completely upside down hundreds of times. North becomes south. South becomes north. The planet's invisible magnetic lines reverse their flow like a river suddenly deciding to flow backward toward its source. Scientists call these events magnetic reversals, and they happen more often than you might expect. Sometimes the Earth's magnetic field stays pointing in one direction for millions of years. Sometimes it flips after only a few 100,000 years. The timing seems random, as unpredictable as the weather, but far slower. When a magnetic reversal happens, all the compass needles on Earth would suddenly point south instead of north, if anyone were there with compasses to notice. But more importantly for our story, all the tiny magnetic crystals in the newly forming ocean floor would align themselves with the new, flipped magnetic field. This creates the stripes that tell the ocean's secret stories. Picture a zebra with perfect black and white stripes running across its body. Now imagine that this zebra is made of stone and lies on the ocean floor, stretched out for thousands of miles. The black stripes represent times when the Earth's magnetic field pointed north, just like it does today. The white stripes represent times when the magnetic field pointed south, in the opposite direction. Scientists discovered this zebra stripe pattern when they began using special instruments to detect the magnetism in ocean floor rocks. They found that the stripes were perfectly symmetrical on both sides of the underwater mountain ranges where new ocean floor forms. The pattern on one side of the mountain range matched exactly with the pattern on the other side, like a perfect mirror image. This symmetry told an amazing story. New ocean floor was forming at the underwater mountain ranges and then moving away in both directions, like two conveyor belts running in opposite directions. As the Earth's magnetic field flipped back and forth over millions of years, it created matching stripes of magnetism on both sides of where the new rock was forming. Reading these magnetic stripes is like reading the growth rings in an ancient tree. Each stripe represents a different period in Earth's magnetic history. Wide stripes formed during long periods when the magnetic field stayed pointing in one direction. Narrow stripes formed during shorter periods before the field flipped again. By measuring the width of the stripes and dating the rocks, scientists could calculate how fast the ocean floor was moving. They discovered that different parts of the ocean floor move at different speeds. Some areas spread apart as slowly as your fingernails grow. Others move as fast as your hair grows, which is still incredibly slow by human standards but remarkably fast by geological standards. The magnetic stripes also revealed the age of the ocean floor. The newest rock, just formed at the underwater mountain ranges, showed the current magnetic field direction. Moving away from the ridges, the stripes recorded progressively older magnetic reversals, like reading backward through time. Scientists realized they had discovered a time machine built into the Earth itself. The ocean floor was a vast recording device that had been documenting the planet's magnetic history for hundreds of millions of years. Every magnetic reversal, every period of stability, every change in the rate of ocean floor spreading was preserved in stone beneath the waves. This magnetic library proved that Wegener's dream of continental drift was real. The ocean floor was indeed moving, carrying the continents along like passengers on enormous rafts. The magnetic stripes provided the missing evidence that earlier scientists had demanded, finally explaining how continents could drift across the Earth's surface. But the magnetic stripes revealed something even more remarkable. They showed that the Earth's magnetic field is connected to the same forces that move continents and create new ocean floor. The planet's interior, with its rivers of flowing stone, somehow generates the magnetic field that protects us from harmful radiation from space. As you rest here tonight, the ocean floors continue to spread. New magnetic stripes form as hot rock cools in the deep sea, recording today's magnetic field direction for future scientists to discover millions of years from now. The Earth's great library grows longer each day, adding new pages to the story of our planet's magnetic memory. Deep beneath the waves, this silent archive preserves not just the history of magnetism and seafloor spreading, but also the record of something even more dramatic and powerful that happens when the moving pieces of Earth's surface finally collide. Imagine two enormous pieces of floating ice drifting slowly toward each other on a perfectly still lake. When they finally meet, they do not sink or bounce away. Instead, they push against each other with gentle but irresistible force. The edges crumple and fold upward, creating ridges of ice that rise higher and higher into the air. This is how mountains are born on our planet, though instead of floating ice, vast pieces of the Earth's crust drift toward each other on currents of molten rock. When these enormous puzzle pieces finally collide, their edges crumple and fold, lifting entire mountain ranges toward the sky in collisions that unfold over millions of years. Right now, as you rest peacefully, this slow-motion dance of creation and destruction continues all around the world. The Himalayas grow taller each year as India pushes northward into Asia like a massive ship sailing through stone seas. The mountains rise so slowly that no human eye could ever detect their growth, yet they climb steadily skyward at the same rate your fingernails grow. Think about the patience required for such monumental construction. Every snowflake that falls on Mount Everest lands on a peak that is slightly higher than it was the year before. Every sunrise that illuminates the Himalayan peaks shines on mountains that have grown imperceptibly taller during the night. The Earth builds its greatest monuments one tiny increment at a time, with the dedication of a master craftsman working on a sculpture that will take millions of years to complete. The collision between India and Asia began 50 million years ago, when India was still an island continent drifting northward across an ancient ocean. Like a slow-moving ferry crossing a vast lake, India traveled thousands of miles over tens of millions of years, carrying its cargo of rocks, minerals, and the fossils of ancient sea creatures toward its destiny with the Asian mainland. When India finally reached Asia, the collision was not violent like a car crash, but irresistibly gentle like two enormous pieces of soft clay being pressed together. The ocean floor between the continents crumpled and folded, lifting layer upon layer of rock that had once been underwater. Seashells and coral reefs that had lived in tropical seas found themselves rising higher and higher, eventually coming to rest on mountain peaks where snow falls year-round. This is why you can find fossils of marine creatures on the highest mountains on Earth. The limestone that forms much of the Himalayas was once the bottom of a warm, shallow sea teeming with life. Ancient trilobites and sea lilies that lived hundreds of millions of years ago now rest in eternal silence on peaks so high that the air is too thin for most life to survive. Mountain building happens wherever the Earth's great puzzle pieces push against each other. The Rocky Mountains rose when smaller pieces of the Earth's crust were pushed eastward against the North American continent. The Appalachian Mountains formed when Africa collided with North America during the assembly of the supercontinent Pangaea. The Alps continue to grow as Africa pushes slowly northward into Europe, crumpling the land between them like a rug being pushed across a floor. But the Earth's surface does not only build upward. In other places, the great puzzle pieces pull apart from each other, creating valleys that grow deeper and wider with each passing year. Where the pieces separate, the ground literally opens up, allowing the planet's molten interior to rise toward the surface. The East African Rift Valley stretches for thousands of miles through eastern Africa like a great scar in the Earth's surface. Here, the African continent is slowly tearing itself in half. The valley grows wider by a few centimeters each year as the eastern part of Africa drifts away from the western part. Millions of years from now, the rift will become a new ocean, separating eastern Africa from the rest of the continent just as the Atlantic Ocean now separates South America from Africa. In the Rift Valley, you can see the Earth's interior dreams made visible. Hot springs bubble up from deep underground, heated by magma that lies not far beneath the surface. Volcanic mountains rise along the valley's edges, built from rock that was recently part of the planet's molten interior. Lakes fill the lowest parts of the valley with water so mineral-rich it supports unique forms of life found nowhere else on Earth. The same process that created the East African Rift also opened the Atlantic Ocean when Pangaea began to break apart. What started as a narrow valley between the continents gradually widened into a small sea, then grew over millions of years into the vast ocean that now separates the Americas from Europe and Africa. Under the Atlantic Ocean, the process continues today. Along the mid-Atlantic ridge, new ocean floor forms as molten rock rises up from the Earth's interior. The ridge acts like a zipper slowly unzipping, allowing the seafloor to spread apart and carry the continents on either side farther away from each other. Every year, New York City moves about an inch farther from London, riding on its piece of the slowly expanding ocean floor. These processes of building and breaking, raising and lowering, happen all over the Earth simultaneously. While the Himalayas grow taller in Asia, the East African Rift grows wider in Africa. While the Atlantic Ocean expands, the Pacific Ocean shrinks as its edges slide beneath the continents around its rim. The Earth reshapes itself continuously, but so slowly that the changes are invisible to human perception. The forces that build mountains and carve valleys operate on a time scale that challenges human imagination. A single mountain range may take tens of millions of years to rise to its full height. The opening of a new ocean may require hundreds of millions of years. By human standards, these are eternal processes, but by Earth standards, they represent the planet's active, dynamic youth. Mountains that seem permanent and unchanging to us are actually temporary features in the Earth's long story. The Appalachian Mountains, once as tall as the Himalayas are today, have been slowly wearing away for hundreds of millions of years. Weather and water have carved them down to gentle, rolling hills. Given enough time, even the mighty Himalayas will suffer the same fate, ground down by rain and wind and ice until only their roots remain. But as old mountains disappear, new ones take their place. The Earth's puzzle pieces continue to drift and collide, ensuring that mountain building will continue as long as the planet's interior stays hot and active. The valleys that open today will become the oceans of tomorrow. The mountains that rise today will eventually wear away, but their place will be taken by new peaks rising from future collisions. As you settle deeper into rest, imagine yourself floating high above the Earth, watching this slow dance of creation and destruction unfold across geological time. You see mountains rising like growing plants, valleys opening like flowers blooming, continents drifting like clouds across the surface of a vast, patient planet. This gentle reshaping of the Earth's surface creates more than just mountains and valleys. It also builds the pathways along which the planet releases its inner fire in spectacular displays of light and power. Around the edges of the Pacific Ocean, a circle of sleeping giants keeps watch over the world's largest sea. These are not giants made of flesh and bone, but mountains built from the Earth's own breath, volcanoes that rise from the ocean floor and tower above tropical islands and distant shores. From your quiet resting place, you cannot hear their song. But if you could listen with different ears, you would detect a deep humming that circles the entire Pacific Ocean like a lullaby sung in the language of stone and fire. This is the song of the Ring of Fire, a chain of volcanoes that stretches from New Zealand through Indonesia, up along the coasts of Asia and Alaska, and down through the mountains of western North and South America. The Ring of Fire earned its name not because it burns with destructive flames, but because it glows with the gentle warmth of the Earth's interior made visible. These volcanoes are windows into the planet's deep heart, places where the flowing rivers of molten stone that move continents occasionally rise to the surface to greet the sky. Think of the Earth as a vast pot of soup simmering on a cosmic stove. Most of the time, the soup stays hidden beneath its lid, bubbling quietly in the darkness below. But sometimes, pressure builds up inside the pot. The lid lifts slightly, and a small puff of steam escapes, carrying with it the rich aromas and warmth from deep within. Volcanoes work in a similar way. They are the Earth's pressure release valves, places where the planet can breathe out the heat and gases that build up in its molten interior. When a volcano erupts, it is not an explosion of anger or violence, but a gentle exhalation from a planet that needs to let off steam. The Ring of Fire exists because of the way the Earth's puzzle pieces fit together around the Pacific Ocean. As new ocean floor forms in the center of the Pacific, the older, cooler edges of the ocean sink back down into the Earth's interior, like the edges of a slow-moving conveyor belt dipping back underground. When these pieces of ocean floor sink deep into the Earth, they carry with them water that has soaked into the rocks during millions of years on the seafloor. As the wet rocks descend into the planet's hot interior, the water turns to steam and begins to rise back toward the surface, melting the rocks it encounters along the way. This creates pockets of liquid rock that are lighter than the solid stone around them. Like bubbles rising through thick honey, these pockets of melted rock rise slowly upward through the Earth's crust. Most of them cool and harden before they reach the surface, but some continue their journey all the way to the Earth's skin, where they emerge as volcanoes. The volcanoes of the Ring of Fire are the Earth's way of recycling itself. Old ocean floor that has traveled across the Pacific for millions of years sinks back into the planet's interior, where it melts and becomes part of the flowing stone rivers that drive continental drift. Some of this recycled rock eventually rises again as volcanic mountains, completing a cycle that has been running since the Earth was young. Mount Fuji in Japan stands as one of the most beautiful examples of this recycling process. Its perfectly symmetrical cone rises from the Japanese landscape like a meditation on geometric harmony. The mountain formed over thousands of years as the Earth slowly built it up, eruption by gentle eruption, layer by careful layer. Each eruption was like the Earth taking a slow, deep breath and then exhaling through the mountain's peak. With each breath, Mount Fuji grew a little taller, a little more graceful, until it achieved the elegant form that has inspired artists and poets for centuries. The Hawaiian Islands tell an even more remarkable story of volcanic creation. These islands rise from the deepest parts of the Pacific Ocean, built entirely from volcanic rock that has accumulated over millions of years. But unlike the volcanoes of the Ring of Fire, the Hawaiian volcanoes form over a hot spot in the Earth's interior, a place where molten rock rises like a slow fountain from the planet's deep interior. As the Pacific Ocean floor moves slowly northwest over this hot spot, it carries each volcanic island away from its source of heat. The island stops growing and begins to erode, while a new island begins to form over the hot spot. This creates the chain of Hawaiian islands, with the oldest islands in the northwest and the youngest, still growing island of Hawaii in the southeast. The volcanoes of Hawaii demonstrate the Earth's gentlest form of volcanic activity. Instead of explosive eruptions, Hawaiian volcanoes often produce slow flows of liquid rock that move like thick rivers of glowing honey. These lava flows create new land as they cool and harden, adding to the islands bit by bit, year by year. Scientists have learned that most volcanic eruptions are not the catastrophic events that movies and television often portray. Most volcanoes give plenty of warning before they erupt, allowing plants and animals to move to safety. The eruptions themselves are usually slow and predictable, more like the controlled release of pressure from a steam engine than a sudden explosion. The Ring of Fire's volcanoes serve as safety valves for the entire planet. Without these windows into the Earth's interior, the pressure from the planet's internal heat might build up to dangerous levels. Instead, the volcanoes provide a gentle, continuous release of the Earth's inner energy, keeping the planet's internal systems in balance. The volcanic soil created by these gentle giants supports some of the most fertile farmland on Earth. The minerals and nutrients released by volcanic eruptions enrich the soil for hundreds of miles around each volcano. Some of the world's most productive agricultural regions, from the rice terraces of Indonesia to the coffee plantations of Central America, owe their fertility to nearby volcanoes. The Ring of Fire also creates some of the most beautiful landscapes on our planet. Volcanic islands rise from tropical seas like emerald jewels scattered across blue silk. Mountain ranges built by volcanic activity form the backbones of entire continents. Hot springs heated by underground volcanic activity create oases of warmth in cold climates. As you rest here tonight, the volcanoes of the Ring of Fire continue their patient work. Most of them sleep peacefully, like great guardians watching over the Pacific. A few breathe gently, releasing small puffs of steam and gas into the atmosphere. Occasionally, one awakens more fully, adding new rock to its slopes in a process as natural and necessary as breathing. These volcanic mountains connect the Earth's deep interior to its surface, creating pathways for heat and materials to flow between the planet's hidden heart and its visible skin. But the stories written in volcanic rock and the patterns of the Ring of Fire represent just one chapter in a much larger book about time itself and how we have learned to read the Earth's most ancient memories. Close your eyes and imagine standing beside a river on a quiet autumn afternoon. Golden leaves drift slowly downstream, carried by currents you cannot see. Some leaves move quickly in the main channel. Others eddy in quiet backwaters, spinning gently in place. A few catch on rocks and stay still for a while before the current finally pulls them free to continue their journey downstream. Now imagine that this river flows not with water, but with time itself. The leaves floating on its surface are not made of oak and maple, but of stone and soil. They are the continents, drifting through deep time on currents measured not in miles per hour, but in millions of years per inch. This is the river where your story unfolds. You live on one of those drifting leaves, riding through time's invisible current on a piece of the Earth's crust that has been traveling for billions of years. Your continent carries you forward through time while simultaneously moving through space, following the ancient rhythms of geological ages. Time flows differently in this river than in your everyday world. A human lifetime passes like a single heartbeat. 1,000 years flicker by like a moment. 1,000,000 years becomes a brief chapter in a much longer story. The rise and fall of entire mountain ranges happens like the slow changing of seasons. In your daily life, you experience time as a straight line moving steadily from past to future. Yesterday flows into today, today flows into tomorrow. But in the river of geological time, events spiral and cycle like eddies in the current. Patterns repeat themselves over vast spans of years. Supercontinents form, break apart, and form again in cycles that span hundreds of millions of years. Scientists call this deep time, and learning to think in its vast scales requires a completely different kind of imagination than the one you use for everyday life. Deep time is not just regular time stretched out longer, like a rubber band pulled until it snaps. It is a different kind of time altogether, where cause and effect can be separated by millions of years and where the smallest changes can have consequences that unfold over geological ages. Consider the simple act of rain falling on a mountain. In everyday time, the raindrop hits the rock, runs down the slope, and joins a stream that carries it to the sea. The event lasts seconds or minutes. But in deep time, that same raindrop is part of a process that will slowly wear the entire mountain down to sea level. Grain by grain, drop by drop, the mountain dissolves and flows away, eventually becoming sediment on some distant ocean floor. But the story does not end there. In the river of deep time, nothing is ever truly lost. The sediment that was once a mountain becomes compressed into new rock. The currents beneath the Earth's surface eventually carry this rock to a place where continents collide. The old mountain, now transformed into different stone, rises again as part of a new mountain range, completing a cycle that has taken hundreds of millions of years. This is how time flows in the geological world. Linear processes become circular. Endings become beginnings. Death becomes birth. The river carries everything forward while simultaneously bringing everything back, like an enormous cosmic recycling system that operates on time scales that dwarf human comprehension. The continents themselves experience time in this cyclical way. North America has not always been where it is today, nor has it always had the same shape. Over deep time, it has grown larger by accumulating pieces from other continents. It has grown smaller by losing pieces to erosion and breakup. It has rotated, drifted across different latitudes, experienced tropical climates and ice ages, all while carrying its cargo of life through time's invisible currents. The rocks beneath your feet have experienced deep time in ways that stretch the imagination. Some have been buried miles underground, heated and compressed until they transformed into completely different types of stone. Others have been lifted high into mountain ranges, then worn down by weather and carried to the sea as sand and mud. Still others have been melted completely and reformed as igneous rock when volcanoes brought them back to the surface. Each rock has a biography written in deep time. The granite countertop in your kitchen once lay deep in the Earth's crust, slowly cooling from liquid magma over millions of years. The limestone in your local buildings formed on the bottom of ancient seas from the shells and bones of creatures that lived hundreds of millions of years ago. The sand at your favorite beach may have once been part of mountains that existed before complex life evolved on Earth. Learning to read deep time requires developing a new kind of vision, one that can see patterns that unfold over millions of years as clearly as you can see waves rolling onto a shore. Scientists have become time travelers of a sort, reading the history preserved in rock layers, fossil remains, and magnetic patterns in the ocean floor. They have learned that the Earth's climate has cycles within cycles, like wheels within wheels. Ice ages come and go in patterns that last hundreds of thousands of years. But these ice age cycles themselves are part of longer patterns that unfold over tens of millions of years. And these longer patterns are nested within even greater cycles that span hundreds of millions of years. The same is true for life on Earth. Species evolve and go extinct in patterns that seem random over short time scales but reveal larger rhythms when viewed across deep time. Mass extinctions happen in cycles. The evolution of complex life follows patterns. Even the chemistry of the oceans and atmosphere changes in cycles that can only be detected by studying time scales measured in geological ages. Understanding deep time changes the way you see your place in the world. Your individual life, precious and unique as it is, represents just one moment in a story that has been unfolding for billions of years and will continue for billions more. Yet you are not separate from this story. You are part of it, made of atoms that have been cycling through the Earth system since the planet formed. The calcium in your bones may have once been part of an ancient coral reef. The carbon in your body may have been exhaled by a dinosaur or absorbed by a plant in a prehistoric forest. The iron in your blood may have formed in the heart of a dying star billions of years before the Earth existed. You are literally made of deep time, assembled from materials that have been traveling through time's invisible river since before the solar system existed. Your body is a temporary collection of atoms that have experienced geological ages, cosmic events, and countless transformations before coming together to form the person resting here tonight. As you settle deeper into rest, imagine yourself floating gently on the current of deep time, carried forward on your continent through the vast ocean of geological ages. You are part of patterns larger than yourself, cycles within cycles that connect you to the deepest rhythms of the planet and the cosmos. But this river of deep time carries more than just the present moment. It also carries the future, flowing toward destinations we can glimpse by reading the currents and patterns that scientists have learned to detect in the stone archives of the Earth's long memory. In the grand ballroom of deep time, the Earth has been dancing for billions of years. The music plays so slowly that each note lasts for millions of years. The dancers are continents, gracefully moving across the floor in patterns that repeat like an ancient, eternal waltz. You know the story of Pangaea, the supercontinent that brought all lands together 300 million years ago. But Pangaea was not the first time the continents had danced together in such an embrace. Long before Pangaea existed, other supercontinents had formed and broken apart in the same slow, majestic dance that continues today. Imagine watching this dance from high above, as if you could see the entire 4 billion-year history of the Earth compressed into a single evening at the cosmic ballroom. The continents would appear to glide together and apart in elegant patterns, each cycle taking about 500 million years to complete. The dance always follows the same basic steps. First, the continents drift toward each other across vast oceans, like partners approaching from opposite sides of the ballroom. As they come together, smaller pieces of land are caught between them and swept up in the embrace. Mountain ranges rise where the continents press against each other. The separate lands become one unified supercontinent. For a time, the supercontinent rests together in the center of the dance floor, surrounded by a single, enormous ocean. But even during these periods of unity, forces beneath the surface are preparing for the next movement of the dance. Heat builds up under the supercontinent. New currents begin to flow in the Earth's interior. Cracks appear in the united landmass. Eventually, the supercontinent breaks apart. The pieces drift away from each other across expanding oceans, like partners separating to dance with others before the music brings them back together again. New oceans form between the separating pieces. The dance floor grows larger as the continents spread apart. But the music never stops playing. The forces that pulled the continents apart eventually reverse direction. The same currents that created new oceans begin to close them again. The continents start their slow journey back toward each other, ready to begin the next cycle of the eternal dance. Scientists have learned to read the history of this dance by studying the rocks that remember each embrace. They have discovered that Pangaea was just the most recent supercontinent in a series that stretches back through deep time like pearls on an invisible string. Before Pangaea, there was Rodinia. This supercontinent formed about 1 billion years ago, when the Earth was still young and life consisted mainly of simple cells without the complex structures that make plants and animals possible. Rodinia brought together lands that would later become parts of North America, South America, Australia, Antarctica, and other familiar continents. But in Rodinia's time, these future continents looked nothing like they do today. They were smaller, shaped differently, and arranged in patterns that would seem alien to modern eyes. The climate was different too. There were no forests or grasslands, no flowers or trees. The land lay mostly bare except for simple mats of bacteria and algae that colored the shores in shades of green and purple. Rodinia lasted for about 200 million years before it began to break apart. As it fragmented, the pieces drifted across a planet that was experiencing dramatic changes. The first complex cells with internal structures evolved during Rodinia's breakup. The first simple animals appeared as the supercontinent's pieces settled into new arrangements. Before Rodinia, there was Columbia, also called Nuna by some scientists. This supercontinent formed nearly 2 billion years ago, in a world so different from today that it might as well have been another planet. The atmosphere contained almost no oxygen. The oceans were rich in iron and sulfur compounds that would be toxic to most modern life. The land was completely lifeless, a world of stone and sky and empty seas. Columbia assembled from pieces of the Earth's crust that were much older than any rocks you can see on the surface today. These ancient landmasses had survived since the Earth's earliest days, when the planet was still cooling from its violent formation. They carried the memory of a time when days were shorter, when the moon was much closer, and when the young sun burned dimmer than it does now. Even before Columbia, scientists have found evidence of earlier supercontinents that formed and broke apart in the Earth's first 2 billion years. These ancient lands existed in a world that was almost entirely ocean, with only small patches of solid crust floating on the planet's molten surface like islands in a global sea of liquid rock. Each supercontinent cycle has left its signature in the rocks that exist today. Scientists can identify the ancient mountain ranges that formed when supercontinents assembled. They can trace the paths that continents took as they drifted apart. They can even determine the climate and ocean conditions that existed during each phase of the dance. The evidence lies hidden in the most ordinary rocks around you. The granite in building stones may contain minerals that formed when ancient supercontinents collided. The iron ore that becomes steel may have precipitated from ancient oceans during the breakup of early supercontinents. The gold in jewelry may have been concentrated by volcanic activity that occurred during the assembly of Rodinia or Columbia. These supercontinent cycles explain many mysteries about the Earth's history. They help scientists understand why certain types of minerals appear in rocks of specific ages. They explain the timing of major evolutionary changes in the history of life. They reveal why ice ages and warm periods alternate over long spans of geological time. The cycles also help explain the distribution of resources like oil, coal, and metal ores. These materials formed during specific phases of supercontinent cycles, when particular combinations of climate, geography, and ocean chemistry created ideal conditions for their formation. Understanding the dance of supercontinents helps geologists locate new deposits of these valuable resources. As you rest here tonight, you are part of the latest chapter in this ancient story. The continents that exist today are the scattered pieces of Pangaea, still drifting apart but already beginning to feel the pull of forces that will someday bring them back together. The dance continues, as patient and persistent as ever. The current phase of separation that began when Pangaea broke apart is gradually slowing down. The Atlantic Ocean, which has been growing wider for 200 million years, will eventually stop expanding and begin to shrink. The Pacific Ocean, which has been contracting as the Atlantic grows, will eventually disappear entirely. When this happens, the continents will begin their slow journey toward a new embrace. The dance floor will grow smaller as the dancers approach each other once again. New mountain ranges will rise. Old oceans will close. And someday, perhaps 250 million years from now, all the world's lands will once again unite in a new supercontinent. This future supercontinent will be different from Pangaea, just as Pangaea was different from Rodinia, and Rodinia was different from Columbia. But it will be part of the same eternal dance, the same cosmic choreography that has been shaping our planet since continents first formed from the cooling magma of the young Earth. Scientists have already begun to predict what this future supercontinent might look like and how the dance of deep time will unfold as today's scattered continents slowly find their way back to each other's arms. In a quiet laboratory somewhere in the world, a scientist holds a small piece of volcanic rock up to the light. To most people, it would look like an ordinary stone, dark and unremarkable. But to this scientist, the rock is a compass frozen in time, a messenger carrying information from deep within the Earth about where our planet is heading in its slow journey through the future. The tiny magnetic crystals inside the rock remember the exact direction of the Earth's magnetic field when the volcano erupted millions of years ago. Like microscopic needles pointing toward an ancient magnetic north, these crystals have preserved their orientation through all the years since the rock first cooled and hardened. By studying thousands of such rocks from all over the world, scientists have learned to read the Earth's magnetic diary. They can trace how continents have rotated and drifted through the past. More remarkably, they can use this information to predict how the continents will continue to move in the future. Think of scientists as cosmic fortune-tellers who read the future not in tea leaves or crystal balls, but in the actual crystals embedded in stones. Their predictions are not based on magic or guesswork, but on the patient observation of patterns that have been repeating for billions of years. Just as astronomers can predict where planets and stars will be positioned years from now by understanding their current motion, geologists can predict where continents will drift by measuring how fast they are moving today and understanding the forces that drive their motion. The predictions begin with measurements so precise they seem almost impossible. Using networks of satellites and ground-based instruments, scientists can detect continental movements as small as the width of your fingernail growing in a year. They measure how quickly North America moves away from Europe, how fast Australia drifts northward, how slowly Africa rotates as it pushes into southern Europe. These measurements reveal that the continents are not drifting randomly across the Earth's surface like leaves blown by the wind. Instead, they follow predictable paths controlled by the currents of molten rock flowing beneath the Earth's crust. By mapping these deep currents and understanding how they change over time, scientists can project continental movements millions of years into the future. Computer models help scientists visualize these future movements. Like weather forecasts that predict tomorrow's rain by analyzing today's atmospheric conditions, geological forecasts predict future continental positions by analyzing current plate motions and the forces driving them. But geological forecasting faces challenges that make weather prediction seem simple by comparison. Weather systems change over days and weeks. Continental drift patterns evolve over millions of years. A small change in the deep currents that drive plate motion might not show its effects for tens of millions of years, making it difficult to test predictions against reality. Despite these challenges, scientists have developed remarkable confidence in their ability to read the future in today's stones. The patterns they observe are consistent with the cycles of supercontinent formation and breakup that have repeated throughout Earth's history. The same forces that assembled and scattered Pangaea, Rodinia, and Columbia continue to operate today. Current measurements show that the Atlantic Ocean is still expanding, pushing Europe and North America farther apart each year. But this expansion is gradually slowing down. Scientists predict that in about 200 million years, the Atlantic will stop growing and begin to shrink as the forces driving its expansion weaken and reverse. Meanwhile, the Pacific Ocean continues to contract as its edges slide beneath the surrounding continents. The Pacific has been shrinking for hundreds of millions of years and will eventually disappear entirely, perhaps within the next 200 million years. When this happens, the lands now separated by the Pacific will be pressed together in a slow-motion collision spanning geological ages. Australia provides one of the clearest examples of predictable continental drift. The island continent is currently racing northward at about 7 centimeters per year, faster than any other major landmass. Scientists can trace its path with remarkable precision, predicting that Australia will collide with Asia in about 50 million years. This collision will create a new mountain range rivaling the Himalayas in height and grandeur. The warm seas that currently separate Australia from Indonesia will gradually close, replaced by towering peaks built from the compressed remains of tropical ocean floors. Plants and animals that have been separated for millions of years will find themselves living on the same continuous landmass once again. Africa's future is equally predictable and dramatic. The continent continues its slow rotation and northward drift, gradually closing the Mediterranean Sea. Scientists predict that the Mediterranean will completely disappear within 50 million years, transforming from a sea into a range of mountains as Africa presses against Europe with irresistible geological force. The East African Rift Valley provides a window into another aspect of continental futures. This great crack in the Earth's surface continues to widen each year, suggesting that Eastern Africa will eventually break away from the rest of the continent. In about 10 million years, the rift may become a narrow sea. In 50 million years, it could grow into an ocean as wide as the current Red Sea. Scientists can also predict changes in the Earth's magnetic field that will affect how rocks record the planet's future history. The magnetic field has been weakening for the past few centuries, suggesting that another magnetic reversal may occur within the next few thousand years. When this happens, compass needles around the world will gradually swing around to point south instead of north. The timing of future supercontinent formation emerges from these various predictions like pieces of a vast puzzle coming together. As the Atlantic closes and the Pacific disappears, as Australia collides with Asia and Africa merges with Europe, the scattered fragments of Pangaea will slowly reassemble into a new supercontinent. Scientists have given this future supercontinent several names. Some call it Pangaea Proxima, suggesting it will be the next version of Pangaea. Others call it Amasia, emphasizing the role that the collision between America and Asia will play in its formation. Still others prefer Novo Pangaea, meaning the new Pangaea. Whatever name it eventually receives, this future supercontinent will bring all of Earth's major landmasses together once again in a single, unified embrace. The world map that future geologists study will look as alien to them as ancient Pangaea looks to us, yet it will be built from the same basic pieces that exist today. Climate scientists can even predict some aspects of what weather will be like on the future supercontinent. Like Pangaea, it will probably have vast interior deserts far from any ocean. The coastlines will experience milder, wetter climates. Seasonal patterns will be dramatically different from anything we experience today. As you rest here tonight, the measurements and calculations that predict this distant future continue in laboratories around the world. Satellites track the slow dance of continents with precision that would have amazed earlier generations of scientists. Computer models refine their projections of where the Earth is heading over the next few 100 million years. But all of these predictions and measurements point toward the same remarkable conclusion: the age of scattered continents that defines our current world is temporary, and the slow currents of deep time are already carrying us toward the next great gathering of all lands into one. Picture yourself floating high above the Earth, so far away that the entire planet appears as a beautiful blue marble suspended in the darkness of space. Now imagine that you have a special gift, the ability to watch time speed by like pages flipping in a cosmic book. Days flash past like seconds. Years blur into moments. Centuries dissolve like morning mist. As you watch from your celestial vantage point, the familiar map of today's world begins to change before your eyes. The changes start so slowly that they are almost invisible, but as the millions of years accumulate, the transformation becomes dramatic and beautiful. The Atlantic Ocean, which has been growing wider for 200 million years, gradually slows its expansion. Like a sleeping person's breathing becoming slower and deeper as they sink into dreams, the ocean's growth becomes more and more gentle until it finally stops altogether. For a moment that lasts several million years, the Atlantic pauses in its growth, neither expanding nor contracting. Then, almost imperceptibly at first, the great ocean begins to shrink. The same forces that once pushed Europe and North America apart now pull them back together. The ocean floor that took hundreds of millions of years to create slowly disappears back into the Earth's interior, like a vast carpet being rolled up by invisible hands. As the Atlantic closes, the continents begin their slow journey back toward each other. North America drifts eastward while Europe moves west. South America follows its northern neighbor while Africa continues its patient northward drift. It is like watching old friends walking toward each other across a vast field, their reunion inevitable but still centuries of millions of years away. The collision between continents happens with the gentleness of clouds merging in a summer sky. There are no sudden impacts, no violent crashes. Instead, the land masses press against each other with irresistible but patient force, like two pillows being slowly pushed together by careful hands. Where the Americas meet Europe and Africa, enormous mountain ranges begin to rise. These new mountains dwarf even the Himalayas of today, reaching heights that scrape the upper atmosphere. The peaks stretch for thousands of miles, creating a spine of rock that runs through the heart of the newly forming supercontinent. The Mediterranean Sea, already small by today's standards, completely disappears as Africa presses against Europe. The Alps grow taller and wider, merging with new mountain ranges that form as the continent's embrace. Ancient seafloors that once lay beneath warm waters find themselves lifted high into the sky, their fossils of tropical creatures now resting in eternal snow and ice. Meanwhile, on the other side of the world, the Pacific Ocean continues its ancient shrinkage. This vast expanse of water, larger than all the world's land masses combined, slowly grows smaller as its edges slide beneath the surrounding continents. The ring of fire becomes even more active as the ocean floor disappears into the Earth's interior, feeding volcanoes that build new mountain ranges around the Pacific's shrinking rim. Australia, racing northward at a speed that seems glacial by human standards but remarkable by geological measures, finally collides with Asia. The warm tropical seas between Indonesia and Australia gradually disappear, replaced by towering mountains built from the compressed remains of coral reefs and ocean sediments. Plants and animals that have evolved separately for millions of years suddenly find themselves sharing the same continuous landmass. As these great changes unfold across deep time, a new supercontinent takes shape. Scientists call it Pangaea Proxima, meaning the next Pangaea. Like its ancient predecessor, this new landmass brings together all of the world's major continents into a single, unified embrace. But Pangaea Proxima will not look exactly like the original Pangaea. The continents that come together to form it have been shaped by millions of years of separate journeys. They carry with them new mountain ranges, different coastlines, and altered shapes that reflect their individual history since Pangaea first broke apart. The new supercontinent might be arranged like a giant horseshoe, with the merged Americas forming one arm and the combined Europe-Africa-Asia forming the other arm, with Australia nestled somewhere in the embrace. Or it might take a more circular form, with all the continents pressed together around a central point like petals of a vast stone flower. The climate on Pangaea Proxima will be as dramatic as its geography. Like the original Pangaea, the new supercontinent will have vast interior regions far from any ocean. These inland areas will become some of the most extreme deserts ever to exist on Earth, with temperatures that soar during the day and plummet at night. The coastlines of Pangaea Proxima will experience milder conditions, with seasonal rains bringing life to coastal forests and grasslands. But the interior deserts will stretch for thousands of miles, creating barriers between different parts of the supercontinent that will influence the evolution of life for millions of years. The single ocean that surrounds Pangaea Proxima will be enormous, dwarfing even today's Pacific. This vast sea will circulate in patterns unlike anything that exists in our current world. Great currents will flow around the supercontinent, carrying heat and moisture in global patterns that will determine weather and climate for the entire planet. Rivers on Pangaea Proxima will be among the longest in Earth's history. Starting in the mountain ranges at the supercontinent's heart, they will flow for thousands of miles through the interior deserts before reaching the sea. These rivers will carve vast canyons and create enormous deltas where they finally empty into the surrounding ocean. Life on Pangaea Proxima will face challenges and opportunities that do not exist in today's world. The vast interior deserts will test the limits of survival, but they will also create opportunities for life forms that specialize in extreme conditions. The long coastlines will provide habitats for countless marine species, while the interior mountains will create islands of cooler, wetter climate in the midst of the desert. Evolution will work differently on a supercontinent than it does in today's world of separated landmasses. Species will be able to migrate across vast distances without crossing oceans. But the extreme interior climates will also create barriers that isolate populations and drive the evolution of new species adapted to specific conditions. The formation of Pangaea Proxima will mark the completion of one full cycle in the Earth's long rhythm of supercontinent assembly and breakup. Just as Pangaea formed from the scattered pieces of earlier supercontinents, Pangaea Proxima will assemble from the fragments of Pangaea that have been drifting apart for the past 200 million years. But even as Pangaea Proxima reaches its maximum size and unity, the forces that will eventually break it apart will already be stirring deep within the Earth's interior. New currents of molten rock will begin to form beneath the supercontinent. Heat will start to build up under the united landmass. The next phase of the endless cycle will be preparing to begin. As you watch this grand transformation from your imaginary viewpoint in space, you witness one of the most fundamental rhythms of our planet. The same patient forces that created the world you know today will reshape it into something equally beautiful but entirely different. And in this distant future, as Pangaea Proxima takes its final form, you are still part of the story, your atoms recycled through countless transformations but still participating in the Earth's endless dance through the river of deep time. Take a slow, deep breath. Feel your chest rise and fall in the gentle rhythm that has sustained you since your first moment of life. In the time it takes you to complete this single breath, North America has moved about 1/10,000,000th of an inch farther from Europe. The Himalayas have grown taller by an amount smaller than the width of an atom. The Earth has continued its patient journey through deep time. You are resting in this moment, but you are also traveling. Not just through space as the Earth orbits the Sun and the solar system moves through the galaxy, but through geological time itself. You are a passenger on a continent that has been drifting for billions of years, carrying countless generations before you and destined to carry countless generations yet to come. The atoms that make up your body have been part of this journey far longer than human beings have existed. The calcium in your bones may have once been part of ancient coral reefs that grew in tropical seas millions of years ago. When those seas closed and the coral became limestone, the calcium waited patiently in the rock until water dissolved it and plants absorbed it and animals ate the plants, eventually finding its way into your growing skeleton. The iron in your blood has an even more remarkable history. It formed in the heart of a star that burned billions of years ago, long before the Earth existed. When that star died in a spectacular explosion, it scattered iron and other elements into space, where they drifted for eons until gravity pulled them together to form our solar system. Your iron has traveled across the galaxy, helped build a planet, and now flows through your veins, carrying oxygen to every cell in your body. You are literally made of deep time. Every element in your body except hydrogen formed in the nuclear fires of ancient stars or in the first few minutes after the Big Bang. You are not separate from the Earth's long story. You are part of it, woven into its fabric, participating in its slow dance through time. This connection goes deeper than the atoms in your body. Your entire existence depends on the geological processes that have shaped our planet over billions of years. The oxygen you breathe exists because ancient bacteria learned to use sunlight and water to make their food, releasing oxygen as a waste product. For millions of years, this oxygen was absorbed by iron dissolved in the oceans, but eventually the iron was used up and oxygen began to accumulate in the atmosphere. The soil that grows your food formed over millions of years as rocks weathered into tiny particles, mixed with the remains of countless plants and animals, and developed the complex chemistry needed to support life. The mountains that create rainfall patterns, the valleys that channel rivers, the coastlines that moderate climate, all of these features formed through the same plate tectonic processes that continue today. Even the magnetic field that protects you from harmful radiation from space is generated by the same flowing currents of molten iron that drive continental drift. The Earth's interior heat that keeps these currents flowing comes partly from the decay of radioactive elements that have been slowly releasing energy since the planet formed 4.6 billion years ago. As you lie here in the present moment, you exist at a unique point in this vast story. You live during a time when the continents are scattered across the globe, when the climate is mild enough for complex life to flourish, when the sun burns steadily and the moon hangs at just the right distance to stabilize the Earth's rotation. This moment in geological time is temporary, like everything else in the Earth's long history. The scattered continents will eventually come back together. The climate will change as continents drift to new latitudes and ocean patterns shift. The sun will gradually grow brighter and hotter as it ages. The moon will slowly move farther away, changing the length of days and the rhythm of tides. But these changes will unfold over time scales so vast that they are almost beyond imagination. Hundreds of millions of human generations will live and die before the next supercontinent forms. Countless species will evolve, flourish, and become extinct. Mountains will rise and wear away. New oceans will open and old ones will close. Yet in all of these changes, the fundamental patterns will remain the same. Continents will continue to drift on their rivers of molten stone. Mountain ranges will rise where the moving pieces collide. Volcanoes will continue to release the Earth's inner heat. The magnetic field will occasionally flip, but it will keep flowing around the planet like an invisible shield. You are part of this continuity. The same physical laws that govern continental drift also govern the chemistry of your cells. The same energy that drives plate tectonics also powers the reactions that keep you alive. You are not just living on the Earth, you are part of the Earth, temporarily organized into the pattern of thoughts and feelings and sensations that you call yourself. This perspective can be both humbling and comforting. Humbling because it reveals how brief your individual life is compared to the vast spans of geological time. Comforting because it shows how deeply connected you are to the planet and to the cosmic story of which Earth is just one chapter. When you feel overwhelmed by the pace of daily life, remember that you are riding on a continent that moves with the patience of deep time. When you feel disconnected from the natural world, remember that you are made of elements forged in ancient stars and shaped by billions of years of planetary evolution. Your thoughts and dreams, your hopes and fears, your capacity to wonder about your place in the universe, all of these arise from matter that has been cycling through the Earth system since the planet was young. The same carbon atoms that form the molecules in your brain may have been carbon dioxide in the atmosphere, sugar in a plant, wood in a tree, coal in a mine, and carbon dioxide again countless times before becoming part of you. As you rest here tonight, the Earth continues its ancient rhythms around you. Continents drift on their slow currents. Mountains grow grain by grain. New ocean floor forms along underwater ridges while old ocean floor disappears into deep trenches. The planet breathes with the patient rhythm of geological time, and you breathe with it, part of the same grand symphony that has been playing for billions of years. In the morning, when you wake and begin another day, you will still be traveling through deep time on your continental raft, still participating in the Earth's slow transformation, still carrying within your body the story of ancient stars and the promise of future worlds that exist now only in the flowing patterns of stone far beneath your feet.